So I don't know about you guys, but I don't like doing subtraction. So especially when decimals are involved, it can be really messy. So what we're going to do is we're going to talk about a decimal hack with subtraction. So you need to make sure you know how to do subtraction in general, how to handle borrowing, and how to work with decimals. So here are a couple of examples, and these are the kind of examples that, when I was growing up, I didn't really like doing these, but I would just kind of power through it. I knew what I needed to do, but sometimes it would just take a long time, especially when borrowing was involved. So I would take this first example, 5 minus 1.273, and I would set it up the way that I was taught, where you line up the decimal point, which is right after the 5, and I would subtract 1.273. But I know that I can't just leave it like this, and I needed to put the zeros here, and I would need to do borrowing or regrouping or whatever they called it. But see, that becomes kind of messy because I can't borrow with the 0 right here. I can't do 0 minus 3 without getting into negatives. And I can't borrow from this guy. I can't borrow from here. I have to go all the way back to the very beginning and rewrite the 5 as 4 so that I can make this a 10, just so that I can rewrite that as a 9 to make this a 10, so that I can rewrite that 10, borrow from there to make this guy a 10, and then I can do my subtraction. And it just seemed to take a very, very long time. But again, when you do like 50 of these, which is what you do when you're in middle school, you just kind of do it over and over again, and you learn a pattern. So here, 10 minus 3 is 7, 9 minus 7 is 2, and then 7, 4 minus 1 is 3. So the setup takes kind of a long time, but I say I'm going to do this a little bit differently. So check this out. I'm still going to look at this as 5 with all those decimals after it, minus 1.273. But here's what I'm going to do. I'm going to completely rewrite this problem, and I'm just going to reduce both of these numbers by 1,000th, because it's easy for me to take 1,000th off of 5.000 and turn that into 4.999. Well, since I made that number 1,000th less, if I do the same thing to the other number, taking 1,000th off of this, so make that 1.272, it's going to be the same difference, because if I have my fingers this far apart, but I move them over here, they're still that same distance apart, although I change their location. That's what I'm doing here. I'm just taking the distance between these guys on the number line, and I'm sliding it by just a little bit. So I'm still going to have the same distance, the same difference, but the math is going to be a lot easier, because look what happens here. 9 minus 2 is 7. 9 minus 7 is 2. 9 minus 2 is 7. 4 minus 1 is 3. There's your decimal, and I didn't have to do any borrowing. Now, granted, this is for very particular situations, but it makes life a whole lot easier for us. Take a look at this next example where I have slightly bigger numbers. This guy has 4 decimal places. Gross. So it would be that minus 6.9078. Now I can do that and do all of the borrowing stuff that I did before, but instead I'm going to rewrite this by taking 1, in this case 10,000th off of 12, which makes that 11.9999. But if I take 1 10,000th off of the other number, it's going to give me the same answer as the first guy would have done. So 6.9077. And you look at this, there's really no borrowing to do. 9 minus 7 is 2. 9 minus 7 is still 2. 9 minus 0 is 9. 9 minus 9 is 0. Now you might look at 11 minus 6, or you may not even see it that way. I have seen some students that'll reduce or like borrow from the 1 to make this an 11. No matter what you do, you're still doing 11 minus 6, so you just get 5. And this is the answer. Again, without having to do crazy borrowing. So maybe if the situation calls for it, you might try this out next time.